All right, in this video, we're going to talk about some of the examples that were done for homework number in section 1.6. I'm going to do a couple of problems that you probably have found to be a little bit more difficult. And this is one right here. This is number 3 in section 1.6. And all the examples here are going to be in section 1.6. But this example is 1 over z equals 5 over the square root of negative z plus 1. And we want to solve for z. Remember, when we're solving these miscellaneous equations, we have to isolate the variable. Meaning we got to figure out ways we can mathematically undo some of the things that are done to z. For instance, right here, we see that z is in a denominator, so we need to find a way to remove it from a denominator. And not only over here is it in a denominator, but it's under a radical. And so one of the first things I'm going to do is I'm going to isolate the z, start isolating the z by raising both sides to the second power so that I can get this z right here from being under a radical. And if I do it to one side, I'm going to do it to both sides. So I'm going to square both sides. I'll get a 1 over z squared equal 25 over, well, when I square this square root, they sort of cancel. They undo each other, so I get 25 over negative z plus 1. Now that I know that I have both z's in my denominator on both sides, what I'm going to do is I'm going to multiply both sides by the lowest common denominator, which is each of those denominators there, and it's equivalent to cross multiplying. So this is sort of the only time we can cross multiply, right? Remember, if we have a over b equals c over d, if I multiply both sides by b times d, it is equivalent to cross multiplying, right? That's kind of where the cross multiplying comes from, all right? Because if I multiply this side by bd, the b is going to cancel and I'm left with that AD. And on this side, if I multiply it by b times d, the d's cancel and I'm left with c times b, right? And so I'm going to do that here, and I'll be left with this equation here. I'll get a negative z plus 1 equals 25z squared. Then I notice that this is a quadratic equation, and we know all of those. This is an A. We know all of the methods that we can use to solve quadratic equations. Since that's a number other than 1 in front of my z squared, I'm going to get everything on one side, 0 on the other, so that I can use my quadratic formula. And so I'm going to add z to both sides and subtract 1. I'll get a 25z squared plus z minus 1 equals 0. Okay, add z to both sides, subtract 1 from both sides. Now I'm going to use my quadratic formula for me to get my two solutions. Negative b, that'll be a negative 1 plus or minus the square root of b squared. That'll be a 1 squared minus 4 times a, which is 25, times c, which is negative 1, all over 2 times a. My a in this example is 25. And so if I simplify that a little further, I'll get a 1. 25 times 4 is 100. If I multiply it by a negative 1, I'll give a negative 100. So I have a minus negative 100 all over 50. And if I continue, that becomes a plus, so I get positive 101 over 50. And so my two possible solutions are negative 1 plus square root of 101 over 50 and negative 1 minus a square root of 101 over 50. One of the things that we have to do is to make sure that we check our solutions. Now, we don't have access to a calculator in our course, and so what I'm going to do is I'm going to do some mental math to help me check the solution here. If I had a calculator, it would make this calculation much simpler. Even if you look at my math lab, they say use a calculator to check your solution, because going through the work to check your calculation in an equation that looks like this, it will take even more steps than the steps that we've used to solve this problem here. So one thing I'm going to notice is that one of my solutions is negative 1 minus the square root of 101 over 50. And this is a negative value, right? Because my numerator is negative, right? And so if I were to plug this into my original equation, I know that this left-hand side over here will end up being negative, right? Because 1 over a negative number is negative, but this right-hand side over here is going to be positive. And the reason why it's going to be positive is because I'm going to put this negative number in here for z, right? But I have to do the negative of that, so which makes that positive. Add 1 of that, that's positive. Take the square root of that, that's positive. So 5 over a positive number is positive. So I know that this one is not going to be a solution. And then my other solution, negative 1 plus the square root of 101 over 50. It is a nightmare to try to plug this in, and I would not have you guys do that. But plug it in for z here, I'm going to get a positive. Plug it in over here, I would get a positive number as well. And so I'm going to say that this is going to be my only solution. Okay.